Hola, folks. Section 5.8 is on the law of cosines. So, we've talked a lot about the law of sines and how it allows us when we have two angles and a side of a triangle to create a unique triangle so that we can solve for different sides and angle measures. But if you also recall from geometry, there was another theorem so it's a triangle congruence theorem called SAS, and it said if you had two sides and an included side of one triangle, they were congruent to the two sides and the included side of another triangle, then the triangles were congruent. So the idea is that using SAS, another unique triangle can be formed, but not using the law of sines. So that's where the law of the law of cosines is necessary. So I'm going to prove to you basically how the law of cosines comes about. And there are three of them. So in this triangle here, I've got a regular triangle ABC that's called an oblique triangle. And I dropped an altitude from A down to the bottom, and we called that point D. So now instead of the side BC just being called A, I need to kind of refer to it as something different. So I'm going to refer to this little piece of DC as X, which would make B to D A minus X. Okay, so what we're going to do first is we're going to I'm going to abbreviate Pythagorean theorem as PT. So we're going to apply Pythagorean theorem for the right triangle on the left, triangle ADB. And if we do that, I'm going to start off with C squared first. That's going to be C squared is equal to A minus X squared plus H squared. And then what I want to do is I want to expand A minus X squared, which is technically A minus X times A minus X. And we need to distribute 4 times, right? So then if we do that, we get C squared is equal to A squared minus 2AX plus X squared, right? Negative X times negative X is plus X squared plus H squared. Okay, then the next thing I want to do is I kind of want to rewrite H because it's not really a part of the big triangle. So in order to do that, I'm going to use the Pythagorean theorem for triangle ADC. And if I do that, then I get, so that implies that B squared is equal to X squared plus H squared. Okay, so if that's X squared plus H squared, notice it is the same here as it is here, which means I can rewrite my next step to be C squared is equal to A squared minus 2AX plus, instead of X squared minus H squared, I already claimed that that is equal to B squared. Okay, and then the last thing is X isn't really a part of our triangle either, right? It's just a portion of the triangle that I put there. So I want to go ahead and remember this is called the law of cosines, so we need to incorporate cosine somehow. So let's go ahead and set up the cosine of angle C. Cosine is adjacent over hypotenuse. So cosine of C, angle C here, adjacent is going to be X over the hypotenuse is B. And remember, we're trying to get rid of X. So if I try to solve for X here and I multiply both sides by B, then that's going to imply that X is equal to B times the cosine of C. So that's great because then I can rewrite the next step. Let me give myself some room here. Then I can rewrite the next step as C squared is equal to A squared minus 2A, but instead of X, I know that this expression is equal to X. So it can be B times the cosine of C plus B squared. And then the last thing I want to do is just rearrange this a little bit. So this is actually equal to C squared equals A squared. I'm going to bring over the plus B squared minus 2AB times the cosine of C. And this lovely looking equation here is actually one of the laws of cosines. We could also notice we drew, in order to create this law, we drew an altitude down from angle A and we created point D, but we also could have, or we could draw the altitude from angle B and make the same law, and we could also draw the altitude from angle C and make the same law. So doing that, we get the full laws of cosine, which are the following. I'll write them in alphabetical order. A squared is equal to b squared plus c squared minus 2b, let me erase that, b squared plus c squared minus 2bc times the cosine of A. There's one of them. The second law is b squared equals a squared plus c squared minus 2ac times the cosine of B. And then lastly, the one we just found, c squared is equal to a squared plus b squared minus 2ab times the cosine of C. These are the laws of cosine, or law of cosines. I don't know, grammatically speaking, which one is correct, because those are three different laws. Either way, I know they kind of seem intimidating, but they actually have some patterns, right? So like a squared, that law, notice, takes the cosine of A. So a squared takes the cosine of A. B squared takes the cosine of B, and C squared takes the cosine of C. So the angle, the cosine angles match that particular side squared. And then the other sides are just literally the other two. So in the first one, a squared, that means the other stuff is b squared c squared minus 2bc. And then the rest follow that same pattern, a squared c squared minus 2ac. Okay, so those are the laws of cosine. Now let's do some examples with it. So I'm going to have you solve for, like, literally solve a triangle, which means, whatever information that I give you, you need to just find the missing information. So there's 6 parts to a triangle, right? 3 sides, 3 angles. So for the first one, I want you to solve triangle ABC. If angle B is equal to 40 degrees, side A is equal to 12, and side C is equal to 6. Okay, now to know which law to use, you want to look at the angle that they gave us. Okay, so the given angle dictates which law to use first. So since I have angle B, that means I want to use the law that has the cosine of angle B for me to figure out everything else. So that's where we're going to start. Okay, so by the law of cosines, I'm going to use b squared is equal to a squared plus c squared minus 2ac times the cosine of b. And I'm going to substitute in what I know. So I don't know b squared, so I'm going to leave that alone, equals a squared, that's 12 squared, plus c squared is 6 squared, minus 2 times 12 times 6 times the cosine of b. So let's just simplify this as much as we can. Oh, wait, lie. Cosine of b, we actually know b, that's why we chose this, silly. So cosine of angle B is 40 degrees. Okay, so when we simplify this, you can actually just type this entire expression into your calculator, make sure you're in degree mode, and when you do that, you end up with b squared is equal to 69.6896 da 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 da. But b is still not isolated. So when you take the square root of both sides, I would make sure in your calculator to take the square root of and then hit second answer. That way your calculator re-enters this crazy long decimal that it has already calculated, and you're not rounding and re-entering a rounded number. So when you take the square root of both sides doing that, you should get b is approximately 8.3. So there's the third side. So you've got the 3 sides of your triangle now, A, B, and C. So we need to solve for our angles. Now, we're going to use the law of sines to solve for the angle, but we need to be cautious. So I need you to recall that there are two angles. So let's just make a side note here. There are two angles, theta and 180 minus theta. And these two angles have the same sign, right? So theta and 180 minus theta have same sign, and I don't mean like sign, S-I-G-N, positive, negative. I mean like the sign is in the y coordinate, right? Because they're both in the first and the second quadrant, so the y coordinate is the same for both of those angles. So what happens is your calculator in the law of sines defaults to the theta. It defaults to the acute option, and it does not take into account that there's an obtuse angle that also satisfies that given ratio. Okay, so the issue is what happens if our angle is supposed to be obtuse? Your calculator is going to miss it. So before you jump into the law of sines mindlessly, I want you to avoid the possible obtuse angle. Avoid possible obtuse angle with the law of sines. Now, how the heck do we know which one is the possible obtuse angle? Well, if you recall back from your geometry days, these are just properties of a triangle. The smallest side is opposite the smallest angle in a triangle. And on the other token, the largest side, or the biggest side, is opposite the biggest angle. So in the scenario that we have here, I already know the three sides of the triangle. We have A is equal to 12, C is 6, B is 8.3. So since 12 is the biggest side, that means that the possible the possible obtuse angle is going to be angle A. So we want to avoid angle A since it might be obtuse. Okay, so that's going to dictate what we choose to do next. When we use the law of sines now, law of sines to solve for angles. So when we use the law of sines now, I want to avoid A first, and I want to go ahead and I already have B, so let's solve for angle C. So since we know B, we're going to use the B ratio. B over the sine of B equals C over the sine of C. So side B we just solved for was 8.3 over the sine of angle B is 40, and that's going to equal C, which we know that value of C is 6. So it's going to be 6 over the sine of C is what we're trying to solve for. So if I'm trying to isolate C, you can think about cross multiplying or just multiplying both sides by the sine of C first and kind of simplifying one at a time, however you want to do it. So in your calculator, when you can go ahead and simplify this part. So like we've got the sine of C times 8.3 over the sine of 40 is equal to 6. You can go ahead and simplify this part or calculate that in your calculator. And if you do that, then you get that the sine of C times 12.9 is equal to 6. Now, I wouldn't round that you can round it on paper, obviously you can't write all the numbers, but don't round it in your calculator. So on this next step, when you divide both sides by that number 12.9, instead of in your calculator typing in 6 divided by 12.9, I would like for you to type in 6 divided by second answer, and it should input that long decimal that it had previously calculated on the step before. If you do that, you'll end up with the sine of C is equal to 0.46. And again, that's a longer decimal as well. To isolate C, I need to get it out of sine. In order to do that, the opposite of sine, or the inverse of sine, is literally sine inverse. So I'm going to take the sine inverse of both sides. It cancels on the left, just leaving me with C is equal to the sine inverse of 0.46, yada, yada, yada. So again, in your calculator, don't take the inverse sine of 0.46. Go ahead and hit second sine, which will do the inverse sine, and then hit second answer, and it should input that long decimal for you as well. When you do that, you'll isolate C, and you should get that C is approximately 27.7 degrees. So there's the second angle. We already knew that angle B from the problem is 40 degrees. We just solved for angle C, so the last thing we need to do is solve for angle A. Well, if you know that the three angles of every triangle add up to 180, then we're simply going to do 180 minus 40 minus 27.7, and we're going to get about 112.3. So then you get that angle A is approximately 112.3 degrees. And as we supposed earlier, 112.3 is an obtuse angle. So, guys, I say that because I made the mistake. I tried to solve for angle A first, and it gave me the acute angle. And then when I went back to check my answer, I was getting incorrect ratios. So I knew something was wrong. So I had to do a little bit of research to figure out why that is and how you should know which angle to strive to solve for first. And I put a link on my webpage to a video that goes into further detail about your calculator's default setting and the difference between that acute and obtuse angle and solving for those. Okay, let's do one more example. Example 2. Similar to this, except I want you to solve triangle ABC. Given not two sides and an angle, but given literally the three sides of the triangle, A equals 20, B equals 12, and C is equal to 28. Okay, so the weird part here is that when we use the law of sines in the last problem, we avoided the possible obtuse angle because we know that the obtuse angle and the acute angle have the same sign. So we had to avoid that until we knew that for sure we were given the correct angle. But in the law of cosines, we actually want to try to determine the obtuse angle off the bat, right? Because we have absolutely no idea what any of the other angles are. So we're going to try to identify the obtuse angle first, because cosine will not be an obtuse and an acute angle that have the same cosine. So we should be able to find it off the bat if there is one. So note, well, let me write down what I just said. That way you write down what we just said as well. Let's see, strategy with law of cosines is actually to find the obtuse angle first, if it exists. Right? It might not have one. Not every triangle has to have an obtuse angle, but if it's there, we want to find it. So again, think back to your geometry properties. We know that, notice C is equal to 28. That's our biggest side. So if C is equal to 28, that implies that angle C is going to be the possible obtuse angle. So we want to solve for angle C first. So that's going to dictate which law of cosines that we're going to choose. So we're going to choose the one that starts off with C squared is equal to A squared plus B squared minus 2AB times the cosine of C. And hopefully we'll figure out if C is obtuse or not. Not that it changes anything else about the problem, but it's the reason that you find it first. So let's substitute what we know. C squared, we know that's going to be 28 squared is equal to 20 squared plus 12 squared minus 2AC will be 2 times 20 times 20. Oh, that should be B. I apologize. Minus 2AB. Okay, so it's going to be minus 2 times 20 times 12 times the cosine of C. And then let's go ahead and simplify this. So 28 squared is 784. Then 20 squared plus 12 squared is 544. And negative 2 times 20 times 12 is negative 480 times the cosine of C. And then we'll go ahead and subtract 544 from both sides. So 784 minus 544 is going to equal 240, is equal to negative 480 times the cosine of C. And if I divide both sides by negative 480, I end up with negative 0.5, which is a lovely number for the cosine of C. So again, to isolate C, right now it is stuck inside of cosine. To get it out, I'm going to take the inverse cosine of both sides. So that's going to leave us with the cosine inverse of negative 0.5 is equal to C. And when you type that in your calculator, you're going to get that C is equal to 120 degrees even. So that's nice. So if C is 120 degrees even, from here, you could continue on with the law of cosines, do the law of cosines again to solve for another angle, or you can switch to the law of sines to go find angle A and angle B, but one at a time. Now, again, you don't have to worry about avoiding an obtuse angle because you already found it. There's 120 degrees, so you can solve for either A or B next. It really doesn't matter. You definitely will use angle C, though, because it's the one that you're given. So if we switch to the law of sines to solve for the other angles, we're going to do C over the sine of C is equal to, let's just solve for A next, A over the sine of A. So we know C is 28 over the sine of, we just found angle C is 120, is equal to, we know the side length of A is 20 over the sine of A. So maybe you would like to think about this instead as cross multiplying. So if you do that, then you end up with the sine of A times 28 is equal to the sine of 120 times 20. And then you get the sine of A times 28 is equal to the sine of 120 times 20 is about 17.3. Again, you get a long number. So then when you do that in your calculator and you divide by 28, leave that number stored in your calculator and then hit divided by 28. And then you're going to get the sine of A is going to equal, would be about 0.62 something, something, something. So then to get A by itself, we'll take the sine inverse of both sides, because that's the opposite of sine, leaving us with A is equal to the sine inverse of 0.62. And again, in your calculator, make sure you hit second sign, second answer, and you should end up with A is going to be approximately 38.2 degrees. So you found angle A just now. You already knew angle C was 120. So angle B is going to be easy as pie, because you're just going to take 180 minus 120 minus 38.2, and you're going to end up with angle B is approximately 21.8 degrees. So those are a couple of examples outlining how to use the law of cosines to solve for, or to solve triangles when you were given either two sides in an angle or when you're given all three sides.